Hello and welcome to this SMARTEC webinar where we'll be introducing the SOFO 7 MuST Universal Reading Unit for SOFO and MuST sensors. We are very excited today to introduce this new readout unit, and in this presentation I will cover the reading unit itself and these applications. A couple of quick information about the webinar. You should hear my voice through your PC and speaker or headsets. If you have any questions, you will notice on the right-hand side of your screen an area called questions, where you can write your questions. And at the end of the presentation, I will answer your question in that same section. Of course, if you have any other questions after the presentation, you can email them to us and we will get back to you in the coming days. We will also publish this presentation on our website as well as the datasheets so that you can re-listen or distribute the presentation to other interested persons. In this presentation I will first give an introduction about the motivation for this new equipment, a quick reminder and overview about the SOFO and FBG technologies, and then I will introduce you to the new SOFO 7 reading unit and its features. We will spend a little time on possible configuration, and finally we go through the main specification for the reading units, and I will then draw some conclusions. The SOFO and fiber Bragg rating sensors are very useful for structural health monitoring, and the use of fiber optic sensor in this area has now become a mainstream application. Several technologies have emerged as dominant, in particular the SOFO sensors for long gauge deformation sensing and the fiber Bragg rating for point, strain and temperature sensing. Additionally, Brillouin and Raman scattering have emerged as the main technologies for distributed sensing. But today we will concentrate more on so-called point sensors, therefore SOFO and FBGs. We have also seen that standards are emerging, and also there is more need for interoperability between different technologies, not only fiber optic sensors but also traditional sensors, so that in some projects we are installing multiple technologies and multiple type of sensor, and the customer really like to have them work together seamlessly. SOFO sensors have been the main product of SMARTEC from the beginning, and they have been used in more than 10,000 cases in over 15 years. It's a very good sensor for measuring structures thanks to this long gauge. Therefore, it measures the average strain over a length that can be of 1 to several meters, and in this way it can measure very accurately the movement of wall structural elements, for example a beam, a column, a rock element, and it has a built-in temperature compensation, so it's not sensitive to temperature variation, and has proven to be very, very stable over many years of application. So it's the ideal tool for long-term monitoring of structures. In the bottom view you can see a typical SOFO sensor, which is composed of two optical fiber, one under tension, the red one we call the measurement fiber. That one is attached to the structure at the two anchor points, the black boxes, and therefore the fiber will become longer and shorter together with the structure deformation. The second fiber, called the reference fiber and depicted in green, is loose and therefore will not change its length when strain is applied. The purpose of the SOFO reading unit is to measure the length difference between those two fibers, because when we have an elongation of the sensor, this length difference will change. On the other hand, if we have temperature changes, the length difference will not be affected, because both the reference and the measurement fiber will be affected in the same way by the temperature. SOFO technology, as we said, offers gauge lengths that can go from 20 centimeters to 10 meters, a resolution of 2 micron, and insensitive to not only to temperature but also to electromagnetic fields, corrosion, etc. We can embed it into concrete or mortars in boreholes, but we can also install it on the surface of existing structures using L brackets. It's easy and rapid to install and measure, and it's ideal for monitoring large structures, especially concrete and geotechnical application. This is because concrete and other construction material can have inhomogeneities, and if you measure strain or deformation over very short gauge lengths of a few centimeters, you could have an influence from local defects, voids, aggregates, small cracks, etc. And on the other end, by using a long gauge sensor, you get an average response that is more representative of the global behavior of the structure in that particular area. Switching to FBG sensor or MuST sensor, as we call them at SMARTEC, they are a complementary technology and has found a lot of application in different conditions. One of the main advantages is that many different types of sensors exist to measure strain on metals, composite and concrete, to measure temperature, to measure tilt, acceleration. And another advantage is, of course, that they can be multiplexed. So it's possible to connect several FBG sensors one after the other and form a chain of sensors in this way. They're also very accurate and very stable, so adapted for long-term measurements. The measurement principle is quite simple. Light source is sent into the optical fiber where several FBGs can be written, and each FBG acts as a reflecting filter. So one specific wavelength is reflected back by each grating, and these wavelengths are then measured by a wavelength device. The good thing about the Bragg grating is that if you apply a strain or a temperature change, the pitch of the grating written in the optical fiber will change, and therefore also the peak of the reflected peak will move, and by accurately measuring these wavelengths change, we can calculate the change in strain or temperature that occurred at that specific location. So the advantages of MuST technology is multiplexing of sensors, combining different sensors in the same line. For example, it's possible to have up to 10 strain sensor or 25 temperature sensor on the same line. But the gauge length is typically limited to 2 meters, so they cannot be as long as the SOFO sensors. And you need a separate temperature measurement sensor to correct the effect of temperature on strain and deformation sensors. An advantage is also that dynamic measurement systems are possible using the same sensor and the same readout units. Now if we look at the combination of those two technologies, we see that SOFO and FBG are really the two leading sensing technology or fiber optic sensing technology for structural health monitoring. The SOFO sensor offers superior performance and flexibility for monitoring deformation in large structure, in particular to measure inhomogeneous materials such as concrete, rock and soil. It also has a lower cost for the sensors themselves. On the other hand, MuST sensor offer the possibility of measuring very different parameters and the ability of being multiplexed. So in real-world application, for example, for monitoring a bridge or a building, it would be ideal to use both technology in the same project. For example, using SOFO sensor to measure deformation of beams and columns, and use FBG sensor to measure temperature and tilt. This was already possible in the past, combining measurements with our SDB software, but you needed a separate readout unit to measure the SOFO sensor and to measure the FBG sensor. So SOFO sensor were compatible only with the SOFO reading unit, and fiber Bragg rating sensor were compatible only with the fiber Bragg rating readout unit. So today we are excited to introduce a new readout unit called the SOFO 7 MuST reading unit that enables the measurement of SOFO and MuST sensor from just one reading unit. So now it's really possible with one unit to measure all type of sensor and combine them in the best possible way for a specific application. How is this done? We are using measurement system which is very similar to the one used for fiber Bragg rating, so a tunable laser that sends multiple wavelengths into the optical fiber. But now instead of measuring the Bragg rating with that swept laser, we connect it to the SOFO sensor with this measurement and reference fiber. When we observe the reflected spectrum from those sensors, we obtain a periodic response, and the period is related to the length difference between the two fibers. So when we take a fast Fourier transform of that signal, we find again the three peaks that are typical for SOFO sensors, and by reading the position of the peaks we can calculate the length difference between the reference and the measurement fiber. So in this way, using our algorithm, it's possible to obtain the same measurement as we did in the past using the movable mirror in the old SOFO reading unit technology. The features of these new interrogators are the following. We offer it in two formats: a portable unit that has 4 channels and a unit designed for permanent installation that can have 4 or 8 channels. And on each of those channels you can connect different things. For example, you can connect one SOFO sensor, you can connect up to 5 SOFO sensors by using an external 1x5 splitter. You can connect a chain of fiber Bragg rating sensors. For instance, you can have up to 7 deformation sensor, 12 strain sensor, or 25 temperature sensors. Or you can combine several FBG chains using an external coupler. We will review all this configuration in the following slides. Each channel can be configured to read SOFO or fiber Bragg rating MuST sensors from the software, so there is no built-in pre-configuration in the unit. If you buy an 8-channel unit, you can then decide that channel 1 and 2 are for SOFO, 3 and 4 are for FBG, and so on. The readout unit also integrates a field PC with SMARTEC software engine and user interface. In this slide you can see the two formats that I've been mentioning before. So a permanent unit that is designed to be attached, for example, to a bridge, and where all the sensors can be connected with 4 or 8 channels. And on the right hand side you can see the portable reading unit, which touch screen and 4-channel connection. Now I will go through some of the typical application configuration that are possible with the SOFO 7 unit. In this first example we are using a 4-channel SOFO 7 readout unit to connect 4 SOFO sensors. So one sensor is connected to each channel and they're measured separately. So it's a very basic and simple configuration. The second example combines now SOFO and fiber Bragg rating sensor. So in this case we have, for example, 2 SOFO sensors and the 2 chains with 3 temperature sensor each based on fiber Bragg ratings. So in this case we have configured the first 2 channels for SOFO and the 3rd and 4th channel for fiber Bragg rating. Another new exciting possibility is to combine several SOFO sensors on the same channel by using what we call a splitter. So this small device depicted here takes one input that connects to the SOFO unit and has 5 outputs that can be connected to 5 SOFO sensors. And in this way it's possible to measure all 5 sensors on a single channel of the reading unit. It's also possible to install this splitter far away from the readout unit, so you can place it, for example, in a junction box, and a single fiber is then used to bring the light back to the unit for all the 5 sensors. So what you see in this picture here are 3 groups of 5 sensors each connected through 3 channels. So if you take, for example, a 8-channel readout unit, you can have 5 sensors on each of the 8 channels, so you can have up to 40 SOFO sensors connected to the readout unit in this way. Finally, very complicated and articulated system is shown in the example number 4. Here on channel 1 we have a splitter with 5 SOFO sensors. On channel number 2 we have a single SOFO sensor. For example, if you need to measure 6 sensors, that would be a clever way to do it, 5 on one channel and the 6th on the other channel. Then on channel 3 we have 3 Bragg rating sensor, and then on channel 4 we have attached a coupler, and on one arm we have a temperature sensor, and on the other arms we have a tilt sensor, an acceleration sensor, and strain sensor. When using a coupler, of course, the different sensors must be fabricated at different wavelengths so that there is no uncertainty on which wavelengths corresponds to each sensor. I would like to point out that the splitter and the coupler are 2 different things. The splitter subdivides the wavelength range into sub-regions and is used to connect multiple SOFO sensors, whereas the coupler simply splits the power into different channels and recombines it, and so is used for MuST sensors. So we sell both splitters and couplers, but they are not interchangeable. The interfacing to the SOFO 7 can happen in different ways. First of all, there is an integrated PC, both in the case of the permanent and the portable reading unit, that runs the SMARTEC's SDB software, and therefore you can use the unit itself to see the measurement, to program the measurement, etc. In the case of the fixed unit, you would have to connect a monitor and a keyboard, for example, during configuration, and then it can be removed. An interesting aspect is also that starting October 1st, so today, the SDB View and SDB Pro are no longer sold separately, but are really included in the base price of the SOFO 7 unit. So basically, for all your projects, you can use them for free and install them on as many PC as you would like. Both the fixed and the portable readout unit have Ethernet access, so they can be connected to an Ethernet network for remote access and remote user interface. So you can use another PC to connect to the internal PC and have access to the database measurements, etc. There's also USB interfaces that can be used to install, for example, a cellular modem for data download and remote monitoring, or any other USB device. So that's the advantages of having a built-in field PC. We can use all type of connectivity, satellite, fiber, cellular, etc. And finally, of course, the portable reading unit has its own touch screen, so that becomes the main interface for that specific unit. A reminder about the SDB View software. You can have a list of sensors. In this case, it would be a combination of SOFO and MuST sensor, but it can also read the traditional sensor, vibrating wire sensor, Actimon, tilt meters, and many other sensors. And then you can display the data in different formats, in table format, in graphical format, and in map format. And with some color coding, you can then create representations to show alarm warning levels with changing colors. The SDB Pro software, you can think of it as an Excel sheet connected to your measurement, so you can define mathematical functions that combine sensors of the same or different type to calculate more advanced configurations. For example, it's possible to
Dato via radio? Tu lo senti, Angelo? Senti? Non ti andare a parlare? Sì.
Sorry, I'm back. We had a small technical difficulty here. So you can use complex mathematical functions to combine measurements, for example, from traditional sensors together with measurements from fiber optic sensor. So for example, you could use a thermocouple to compensate the strain of a fiber optic sensor. Now let's review some specification for the different readout units. Here you can see for the reading of SOFO sensor in the first column and reading of fiber Bragg rating in the second column. The resolution is 2 micrometers for SOFO sensors, as it was with the past readout unit, and 1 picometer for MuST sensor. Accuracy of 2 per mil and 1 picometer. We can take one measurement per second. A measurement range of 50 millimeters for SOFO sensors and 100 nanometers for Bragg rating. And this means that we can measure 5 SOFO sensors on each of the sensor channel by using the splitter, or we can use 7 FBG sensors, 12 SOFO sensors, and 25 FBG sensors on the Bragg rating channel. The unit doesn't need any calibration for SOFO sensor, and for FBG it contains a NIST traceable wavelength reference that ensures very accurate and stable wavelength measurement. The connectors remain E2000 PC for SOFO sensor and E2000 APC for Bragg rating. Typically it takes about 2 seconds to read each sensor and store the result in the SDB database, that both for SOFO channel and for FBG channels. As mentioned before, the permanent unit can have 4 or 8 channels, and the portable unit can have only 4 channels. Here are some information about the characteristic of the readout unit itself. So it's in the case of the permanent unit, it's a box of 50 by 50 by 21 centimeters, about 25 kilograms of weight, and contains a data logger that can store data for very long periods of time. And for a portable reading unit that you can see here, can be powered by AC power or by the built-in battery or an external DC power supply. It also has Ethernet and USB connection, and a 12-inch touchscreen that is used for user interfacing. So it can be used in the field, in field conditions with the touch interface. Also in this case, the data is saved in SDB format. The unit is 7 kilograms, so it's relatively lightweight, certainly much lighter than the previous reading unit, and can operate again in field conditions. So this brings me to the conclusion of my presentation. We're very happy to introduce this new SOFO 7 MuST reading unit that can now measure both SOFO and MuST fiber Bragg rating sensor. So it becomes possible to mix and match SOFO and MuST sensor as required by each project. So you can have the best of both worlds without having to multiply the investment for two different readout units. Very interesting new feature is also that SOFO sensors can now be multiplexed using the splitter. So that's no longer a characteristic only of fiber Bragg rating, but even SOFO sensor can be combined together to use 5 sensors on the same channel. We are offering the new unit in portable and permanent format, and the unit integrates with the well-known SDB software for data acquisition, management, and user interface. This is a unique solution on the market offered only by SMARTEC and is available immediately. In fact, we had some projects where this system is already deployed. We have almost 7 units now produced and used in the field already, so you can use this technology immediately. In terms of pricing, we'll be happy to provide you with quotations, but as a general guidance, the new reading unit has a cost that is lower than the previous SOFO reading unit, plus the fact that we no longer charge separately for the SDB software brings some additional saving. So I hope this presentation has been interesting for you, and maybe you will find some good application for this new technology. So this concludes my presentation, and if you have any question, please write your question in the question panel, and I will be happy to answer them shortly. Thank you very much.